Okay, I think it's 1 o'clock. Welcome. It's 1 o'clock. It's time for our clinic. We didn't have a clinic last week because of the ECP meeting, but hey, everybody who made it here today, welcome. I'm going to stop here. I checked our Google Sheet. There weren't any questions there, but for those of you who are here, are there any questions at this point? And I'm going to
not a question, but a comment. But maybe you will get it. That confusion about current working directory location of the file, it's all over the places. So
I'll come back to that later.
Okay.
But
Okay.
Great. Any other questions? No. Okay. We'll pause many more times. Okay, so we got a lot of things to get through because we missed last week. Announcements, again, registration for the HUG event closes Sunday, May 15th. So if you want to be part of it in person, online, submit a presentation, hurry because you have time until next Sunday. We had a Hermes 060 beta release, and among other bug fixes and whatnot, the highlight is that this time we released the Hermes HDF5 virtual file driver. So what that means is that you can load, if you want to take advantage of the Hermes buffering system from an application that uses HDF5 for I/O. You can just create a file access property list and select the Hermes virtual file driver, and then take advantage of the storage hierarchy and hopefully get better performance. And there is a link here. So here's the link to the GitHub repo where you can find the code, but also some documentation around that virtual file driver. Other news, HDF 112.2 is out. Newsworthy are the following: the parallel compression improvements that were made in develop. They were sort of merged into 112.2, so they are available there. For all the macOS fans, there is now support for the Apple M1 chip with macOS and so forth, and the Clang version 12.05. And for users of HDF tools, beware that I think several tools supported these sort of, I'm going to call it like auto-completion-like things where when you specified a command line option in the long form, typically you could specify just the beginning of that long option name, and but that was there was a lot of code associated with that and so forth that maybe wasn't really worth it, and not just only maybe wasn't really worth it, but in a way deprived ourselves of because it in a way lit up the namespace, so it ruled out certain other things that might be useful, and so this convenience, if you want to call it that, was removed from all tools in 112.2, and so just beware of that if you have scripts where you exploited, in double quotes, this ability, maybe that those scripts might break or behave all of a sudden in an unexpected way. So beware of that. And that's with 112.2 only, but it might be, I don't know what the plans are. We might do that in other versions as well. Okay, and then another announcement here tomorrow. So the ECP workshop or conference is ongoing right now, and usually, yeah, you have to register. You typically have to be an ECP project member to attend the sessions, but right now they are in a phase where they have these so-called community Birds of a Feather days, and there will be a Birds of a Feather where we talk about sharing the experience with wall connectors, development and maintenance considerations, and that will take place tomorrow between 1 and 2 Eastern time. And this is open. This is an open registration event in the sense that, yeah, you may not be registered to attend any other ECP events or talks, but for this particular one, and there might be a few others, you can register. You don't need to be affiliated with the ECP project in any shape or form, but if that's of interest to you, feel free to register and yeah, hopefully learn something interesting. Okay. Any questions? I'm going to pause here because then we will switch to the forum. Are there any questions about this or any other HDF related things?
No questions, Gerd.
Okay, thanks. Welcome. Okay, then let's jump to the forum. There, yeah, as we're looking at 2 weeks here, there were lots of interesting things. And here's my sort of my biased selection, or what stood out to me, what I thought might be of a more general interest. There was one question about hyperslab selections. The user said that, okay, I'm making a hyperslab selection. And as we all know, these hyperslab selections can be combined using sort of set theoretic operations. By that I mean sort of the union, the intersection, the difference, and operations like that. And he noticed that when I believe he tried to do a union, so it would be an H5S select or, so the logical logical counterpart of the union would be an or. And what the user noticed was that when he ORed these 2 hyperslab selections, that the order actually was not, when he then did the read operation or the write operation, I forgot which one, he was surprised that things were not in the order that he expected it. And so what I wanted to point out is that, yeah, I think definitely for efficiency reasons and implementation complexity reasons and whatnot, if you make these types of set theoretic operations on hyperslabs, there is an implicit and depending on whether you use C or Fortran order of these selected grid points. So if you think about these selections, these hyperslabs where you have sort of these contiguous regions patterned in a way, and then you can combine multiple of them through intersection or through union and so forth. If you think about it, so C order means that, yeah, there is a certain order which dimension is the fastest changing, where the coordinates, so to speak, are fastest changing, the array indices, I should say, faster and slowest changing. And that dictates I wouldn't call it lexicographic order, but sort of a canonical order on these grid points. And so when these selections are being processed as part of a read or write operation, the iteration happens in that order. And that may or may not be the order that you want, but that's how it's implemented at the moment. And yeah, so there, and at the moment, there is no facility that you can influence that order. You can certainly combine that, but you have to do that on your own with some kind of post permutation. So you can do a scatter, it would be a scatter or getter operation, whichever way you want to look at it. You can do that in addition to doing this type of partial I/O. However, you would have to do that on your own. There is, with the standard selections and then reads with selections or writes with selections, there is no facility where you can override or modify that order. The thing, and this is more of a question to myself, I didn't have a chance to look into into any details. So this applies to hyperslab selections. Off the top of my head, I'm not sure. Let's say I have 2-point selections, so where rather than selecting sort of patterned ranges of grid points, you explicitly enumerate the elements, the grid points that you want to select. And then if I take the union of the two, well, first of all, the library would have to evaluate that union in the sense that, yeah, if most likely there will be some element, unless the union is disjoint, let's say the union is not disjoint, then there will be certain elements that occur twice or multiple times in those selections. And I'm, off the top of my head, I'm not sure what the library does. I mean, it could do the same thing and superimpose that canonical order, but I don't know. Elena, do you happen to know what happened?
I believe, if I recall, there is API to get your selection back. Just list of points, and it will be ordered. So
okay.
My guess will be that it is ordered, but needs to be checked.
Okay, good. So I'll take that as a homework. And actually, I should have thought about this. I could have written a small example, but I'll take that as a homework for next time to check on that. But anyway, so this was one interesting question. Another one that was more sort of a syntactic thing. Someone was asking about sort of conventions for naming HDF5 files and if they had any importance or any significance. And from a technical perspective, no, because the way the HDF5 library and other tools determine whether a file is an HDF5 file is purely based on the content of that file. And you can call this .word or .html or .txt. It doesn't really matter. The library will open that file, look for the HDF signature and whatnot. And so it's not going to be confused by the extension. However, as my colleague Ellen pointed out, for some of the tools, it makes good sense to not go too crazy or to be too obscure about what kind of file this is, because a tool such as HDF View uses a certain search filter or pattern when it sort of looks at the working directory and tries to be helpful and say, here are some candidates for HDF5 files based on the extension either being star.h5 or star.hdf5. So depending on how helpful you want to be to others or how difficult you want to make your life, stick with these simple extensions. But then again, if you have the liberty to choose a completely different convention, that's fine too. There's no technical reason to stick with .h5 or .hdf5. Okay.
And, Gerd, I was going to reply, but then I decided I need to talk to you first, guys. I believe what Ellen meant in HDF View, when you open, it highlights H5 and HDF files with those extensions, right?
Yeah, yeah.
HDF View has an option to actually change this and highlight whatever files. You can highlight all files, right?
Okay.
But maybe we should extend it, because now there are NC files, which is a common convention for NetCDF. And if it's and HDF4, if it's HDF4 NetCDF file, HDF4 will be able to read this too. So it makes sense for NC. And then there are Nexus files, which I believe they have extension NX. So we can try to be a little bit more helpful here. But once again, on another hand, you can easily trace and see which files are HDF5 files. Because there is an API and highlight all HDF5 files. And that's what I was going to respond, but it's not there. But it will be good because it is confusing sometimes.
Yeah, no, definitely good point. Yeah, and we should, definitely for NetCDF4 files, for Nexus files and so forth. Yeah, Great, thanks. And you might still reply. I mean, I'll make a note of it because we will have the recording, but if you don't mind,
do you want me to reply? I will. Mm-hmm.
Please, yes, if you would, that would be great. Okay, then the next one is still up in the air. It's an interesting post, and actually the person who asked it actually posted one of the pictures from one of our users guide or something about the IO pipeline and so forth. And on reading his comment, I actually realized that I misunderstood his initial post, but we'll get to that in a moment. So his question was basically, he's using H5Py, and in H5Py for data sets, you have two methods. Well, one of them is available only for chunk data sets, this write direct chunk. But then for all data sets, there is this write direct method available in H5Py. And my understanding is that write direct in H5Py, what it does is it is available only for situations where you have a contiguous buffer in memory that you want to write to that data set. And what H5Py then ensures is that there will not be any copying of that data, but that buffer will actually be the one that gets passed to H5D write in this case, so the C API, H5D write. And so yeah, and they call that write direct. But it's not direct in the sense that there are alignment constraints or anything else. It's really, yeah, it avoids a mem copy and is in a way the most direct path to the C API, so to speak.
And they are not using direct driver, right?
No, they are not using, it's not related to the direct VFD, no. Mm-hmm. And then as a second option, there is this write direct chunk, which in the HDF5C API would map to, well, first of all, it works only for chunk data sets. And secondly, it maps directly, instead of H5D write, it maps to H5D write chunk. And we know that H5D write chunk was introduced originally, yeah, to give the user full control over creating a buffer in memory that they know has the right type, if there was any kind of filtering or transforming that needed to be done, and they could do that. They thought they could do that more efficiently in memory with a GPU or other auxiliary hardware. And then they just said, here's a chunk, put it straight into the file. Don't run it through data type conversion, selection, and filter and whatnot. Just put it straight, call p-write, the POSIX write operation right there. And so that's what H5D write chunk is about. Now, what this user noticed was that there was about a 50% difference in performance. And his question is obviously why? Why is that? Now, and he provides a little incomplete snippet of Python there. But where I went wrong initially was I thought he had used write direct and write direct chunk, both with chunked data sets. However, when I read his latest reply that he posted around lunch today, I had a chance to briefly look at it, but didn't have time to sort of digest it. I think he's actually, where he uses write direct, he uses that actually with a contiguous data set and not with a chunk data set. And that explains his, or sort of makes his confusion. I mean, I'm equally confused. If he uses write direct with a contiguous data set, I would expect that to be actually slightly faster, but definitely on par with write direct chunk, unless the chunk size is ridiculously small. But that's not the case here. The chunk size is really good and substantial. So at some point you think that the overhead is just so small that you wouldn't see a difference between writing to a contiguous data set and writing multiple, albeit substantially sized chunks. So that 50% difference makes no sense whatsoever to me. I mean, I would expect the difference to be in the noise, maybe a few percentage points, yeah, less than 5%, and at that point it's in the noise. Right, and then what he basically, this is a copy from his, and which drove it home to me. He explicitly said there's no data conversion and whatnot, but no scattering. He has contiguous layout, and there's no chunking, no filters, and so forth. So yeah, I'm puzzled by that. Now I do remember, I think Wei King chimed in at some point and said that we rediscovered multiple times the fact, and sort of probably everybody, including myself, rediscovers that simple fact over at least once, is that when we look at the allocation time and the writing of fill values, under certain circumstances, you actually do, you potentially do twice as many writes as needed, in the sense that you write once all your data as part of the allocation and then write fill values before you then actually write the payload, the true values that you want to write there. And in a second instance, and there is a way, since through the API you have to control over when something gets allocated, whether it's chunked or whether it's contiguous, or under what circumstances fill values are actually written, or you can actually disable the writing of fill values. Now, so Wei King was suggesting that maybe because also the 50% figure looks suggestive, because you might say, well, yeah, if you expect that write for this scenario, write direct and write direct chunk, which should give you roughly the same performance, and then you see a 50% difference, you could say, well, if write direct or writes twice as much data or writes the same data twice, well, that would explain a 50% difference. But then I think the person who asked the question replied and said, well, according to our documentation, the sort of the allocation and fill time strategy is such that that shouldn't be a problem. But I have to go back and check that more carefully. But I think I understand now, or I appreciate the disbelief that why would contiguous be so much slower than direct chunk? I have no explanation. Given what I believe is the case here, I have no explanation for it.
And I would rerun experiment. I would not believe it.
Mm-hmm.
Yeah. It may depend on the system, and it also can be effect of H5 pi, where for write direct chunk they go immediately to low-level APIs, while H5 pi does something with write direct more caches, or because they work with objects, whatever this object does, I simply don't. But I don't believe. I agree with you that it should be the same, about the same performance.
Okay, good. And then I have a slightly longer example, but which is also very interesting. So I want to make sure I cover it. But before I do that, I want to quickly mention, what Elena pointed out earlier is somebody pointed out that there seems to be incorrect information in our documentation, and the specific call here is when you use so-called external layout, then you have to think about where does that external data, the values of your data set that are not stored in the HDF5 file, where are these files that contain the dataset elements located with respect to the HDF5 file. That's one approach, but then also the question is, well, how does that relate to the working directory of the application? And it appears, well, it not just appears, our documentation says that the position by default, the position of these external data sets is relative to the location of the HDF5 file, but then the user sort of quoted parts of the library code that shows that that's not correct, that the default location of these external files is actually relative to the working directory of the application and not the HDF5 file. So we certainly thank him for pointing that out, and I created a GitHub issue, and I think, yeah, Elena, as you just pointed out, that appears not to be the only place in the documentation where this is incorrectly
we
stated.
just need to check for VDS where we have external storage, because there was a confusion between current working directory where file is relative paths, and even HDF5 file will be interpreted relative to current working directory, right? And it's very possible that external files were interpreted at some point as relative to file location. So it can be, that's why, and I know HDFU had a problem with this also, confusion. So we need to, and by the way, it may be correct at some point, and then it was changed. So we need to straighten it. Yeah. Have our story, right?
Right. No, but and I'll add that to the GitHub issue to whoever gets the job of checking that to take a broader view rather than looking just at this one function.
External links also, right?
Yeah, external links probably, yeah. And for some of these, there are environment variables where you can control this. In this particular case, for external layout, I'm not sure if there's an environment variable that would control that. But okay, well then let's, this was a very interesting topic, and it's also ongoing, but we are making progress there, I think. This is something as an error that we have seen in the past, but there is actually an interesting twist here. So the user, was there a question? Okay.
Yeah. Gerd, there is a question that Elena kind of answered in the chat too. So someone said they're new to HDF5 format, planning to include it in their workflow. We mainly use R and basic shell programs. Are there any posts comparing performance, size on disk, read specific rows, columns of HDF5 with databases, SQL, and other data formats, FST, Feather? So then Elena said, the HDF group doesn't have those benchmarks. She suggested they post on HDF Forum. And then the end question was, would you expect HDF5 to be faster than, say, SQLite database for simple reads to pull columns and rows from a data matrix?
I would say it depends. So things can certainly be optimized in the sense that if you know I'm going to always access them in a row-wise fashion or always access them in a column-wise fashion, then that's how you can just lay them out on disk. And then if it's just a straight read, it's going to be as fast as it can be, and probably as fast, if not faster, than SQLite or whatever system you have. However, if you say, well, I typically have a mixture of row-oriented accesses and column-oriented accesses, then you would apply blocking in the sense that you can't have it perfectly in row order and you can't have it perfectly in column order. However, you can create these things. We just talked about chunks. Think of them as blocks. So rather than having perfect column, or row, you just have a certain block size, because you know you will be reading, you will be throwing away certain data that you will not use in that block, but by just choosing a block size that sort of strikes a balance between you can't afford the cost of doing a transposition on the fly between row and column layout. You just say, okay, the penalty is going to be that I will be reading some rows or parts of some rows that I will not be using, or I will be reading parts of some columns that I will not be using. So you will be, in a way, wasting memory bandwidth here. But you will come out ahead because this blocking scheme gives you sort of the middle ground. It gives you, it's not going to give you top speed for row-oriented access, and it's not going to give you top speed for column-oriented access. But on average, it will give you, in a way, what's achievable, so to speak. Because reads, if you do reads of the right size, they're very fast anyway. So the system is going to read more data than you use anyway, whether you control it or don't control it. It has to do with, in the simplest case, cache lines. The cache lines have a certain length, like 4 double precision floating point numbers. The system will read those 4 floating point numbers anyway, even if you use only one of them. You have no control over that. So I would say it depends, but there is a good chance that HDF5 will do as good, if not a better job. Okay. Okay, so let's maybe, we are out of time. Maybe, yeah, I would like to talk about this a little more. So I hope we will have a complete picture next week. So maybe I'll just not talk about it here, but you have the link. So if you are curious about this topic, there might be an issue in the library, and it's not clear to me if that issue cropped up in 112 and wasn't there in 110, but it's an interesting story. And fortunately, we have a reproducer and so forth. The user originally provided a C++ example, but then sort of we stripped it down to C, and we can also reproduce it in C. And now it's only a question, yeah, was it there in 110 already, or is this something that we introduced with the vol layer, for example? But at the heart of this is really how the library keeps track of open handles and so forth. And it seems to get, definitely in 112, it seems to get confused by if, as a result of a disk full type error where a write doesn't succeed, even if you then sort of redirect and you find a location, another disk drive or something like that, where the writing can succeed, it succeeds, but then at the end of the application, when it shuts down, an assertion gets triggered and the whole thing crashes, which is not what should happen. And this is what this user discovered. And so now we have to work out where that's definitely a defect, it shouldn't happen, and how we can fix it. And so, yeah, we'll talk about this more next time. Anyway, thanks for coming. Thanks for asking great questions. And I hope to see you next week.